All right, hello. This video we're going to be going over Chapter 8 review, which is about rational expressions that kind of look like this. Have out pencil, paper, and try the questions before watching my solutions. That's what the final is going to be like, is you have to try it on your own or do it on your own. So practice that process while reviewing these questions. Okay, so the first question here is, what type of variation is it? Is it direct, inverse, or neither? And remember, a direct variation is just like when you get paid at your job. You get $10 an hour, or maybe you make 8 phone calls per hour or something. That's a direct variation. And then an inverse is where you have a constant divided by x. So like if you have 100 cookies and divided amongst x people, that's an inverse, a fixed number divided by x. So pause the video and see if you can figure out this question. So a good trick for inverse direct is if as x goes up here, y goes down. So that's going to be inverse. If they both went up together or both went down together, that's going to be direct. But because one is up, one is down, that's an inverse relationship. Okay, and then to write the equation, you kind of got to see the pattern in the table, which here, if you look, when you multiply x times y, you always get 20. 2 times 10, 4 times 5, 5 times 4, 20 times 1, you always get 20. So that's our equation. Other than usually they write it with y alone. So if we divide everything by x here, we'd have y equals 20 over x, and that's the more traditional way to write an inverse. It's like a fixed amount divided by the number of people. So that would be the equation that models it. Okay, one more like that. Pause the video, give it a shot. Okay, so this one is up, up. As x goes up, y goes up. So it's either going to be direct, or I guess it could be neither too. But it's likely, let's just see, this one's going to be direct. And you can almost kind of tell that like y is just 6 times whatever x is, right? If you take it times 6, times 6, times 6, times 6. So that's our equation. The other route is you can divide the pairs. If you do y divided by x, so I'm doing y divided by x here, and you get the same thing each time. That's another way to tell that it's direct. So we could say y divided by x is always 6. These are all 6. And then if you multiply both sides by x, you'd get that equation. Right? So there's a lot of ways to do it, but basically a direct is a fixed number times x. Okay, so this one we know is an inverse variation, and we want the equation for it. So when it's an inverse variation, we know it's y equals k over x. So see if you can figure out what would be the k value here. Okay, so they give us a fact that y is 8 when x is -2. So if we put that in, then we can say, well, if that is true, what does k have to be? And so you could solve this. This is a divide -2, so take both sides times -2. And that would tell us that k is -16. Okay, and that's all we need for our equation. Just plug it in, and now our equation is y equals -16 divided by x. And that's what an inverse looks like again, a fixed number divided with x. Okay, so then we got into graphing. So that was direct and inverse variation, but then we started to graph in the most basic shape. If you forget what this looks like, you can just graph it. So if you want to see what an inverse looks like 4 over x, or anything really on the final, you're not sure what it looks like, just graph it. So I'm in y equals here, and I'm going to do 4 divided by x. Okay, and that's what the basic inverse looks like. It's like half a ninja star. Okay, and so the asymptotes are the x-axis here and the y-axis. We want to say, what would the equation be if the asymptotes were -2 and -4? Okay, so you don't have to graph it, but usually I graph this to make some sense of it. And then we just got to modify the equation based on those asymptotes. So I'm going to draw a picture of it really quick here. Okay, so I've drew in the asymptotes, and we have, this one is x equals -2. The horizontal there is y equals -4. And so our graph is now down here, right? Our ninja star got shifted. Okay, and the reason why I like the picture is I can see that we shifted left. Nope, we went left, not right. Left, 2, and down by 4. All right, And so then I just need to modify this equation to make it go left 2. So that would mean with x, I'm going to add 2. Remember, that's the opposite of what you think. You think minus 2 would make you go left, but we're going to add 2 to x. That'll make us go left 2. And then down 4, just put a minus 4 in back. So that is our answer right there. And I like to think about it visually when I answer a question like that. Okay, so this one is going the other way. We're going to actually graph it. We're going to draw any asymptotes we have and then graph it from there. A good reminder again is you can definitely check on your calculator. Just when you're entering, make sure you put like parentheses around that to graph it. So yeah, pause the video, give it a shot. All right, so this is our ninja star shape, right? Again, if you're not sure of that graph, but you'd see it's a ninja star. And this right here makes us go, let's see, left 1, and then the +3 makes us go up 3. So instead of being centered at 0, 0, we're going to be centered left 1, up 3. So we're going to be centered right there. And then I'm going to draw some asymptotes through that point and then sketch my ninja star around that. So I can see if I can get a line here. So there's y equals 3, x equals -1. I guess we could label them just to be 100% accurate. So this would be x equal -1. This one would be y equals 3. And then our graph, I guess it has a stretch. Because of this too, it's going to be stretched. But generally, we don't have to worry too much about what the stretch looks like. So just draw it in the ninja star positions like that. And then remember, if this were a negative up top, it would be here and here. But because it's positive, it's right there and there. And again, if you're unsure of this one, your calculator is going to be your buddy on this question. Okay, so the other type of graph, this is kind of the basic one where the numerator is just something simple. But then if it's something complex, then we had all these different things for like finding horizontal asymptotes and finding holes and all that stuff. So the first question is finding a horizontal asymptote. And I guess your hint on this is that MN chart, which will be given to you on the final. And so see if you can look at that chart and figure out what would be the horizontal asymptote. There should be a note sheet out somewhere on Schoology in the finals folder. So if you want to look there, good place to start. Okay, so M and N are your highest exponents. So we have M4 and N3. So that means M is greater than N. And so if you look at that note sheet, when M is greater than N like this, there is no horizontal asymptote. Okay, and so you can just look back at the chart and look it up, figure it out that way. And if you want to review the rest of the chart, I encourage you to find it out on Schoology. Okay, so pause the video, see if you can remember what discontinuities are. Okay, so discontinuity is a break in the graph. So if this wasn't clear before, when you have a graph, whether it's a rational function or anything else, it's just a bunch of xy points. So say that we had a graph that looked like that or whatever. These are just a bunch of xy points. Okay, and a discontinuity is where there isn't an xy point. Okay, and that's going to happen for an x value that makes the divide by 0 situation. So for example, like if I wanted to do x of say 5, I could do 5 and then plug in 5 for x and figure out what y is, and that would get me a point on the graph. Right? But what I can't do is put a 1 for x, because if I made x 1, then my numerator would be, I think, 1 minus 3 plus 2. I think actually the numerator would be 0 and the denominator would also be 0. But the significant part is like you can't have this 0 down here, right? You can't divide by 0. That's going to create an error. So we say that the graph breaks. So in our graph at 1, right, wherever x is 1, there's a break. And it could be at a vertical asymptote or it could be a hole, right? It really depends on the graph. And you could graph it on a calculator and figure it out. But the point of this is our point of discontinuity is 1, right? That's going to be the discontinuity. So if they ask you about that, it's like, where does the graph break? And it breaks whenever the denominator is 0. In this case, 1. Okay, so discontinuities, can be broken into either vertical asymptotes or wholes. Okay, and so there's still like discontinuities are always when the denominator equals 0, but then there can be either a whole or an asymptote there. So see if you can remember how to tell which it is. So find the discontinuities and label as whole or asymptote. So our discontinuities happen when the denominator is 0. So we've got it in factored form, which is great. So just set each little part to 0, x minus 5 or x minus 3. If the whole thing multiplies up to 0, then one of the two parts has to be 0, meaning our breaks are at 5 and 3 if we solve those. And then to tell if it's a whole or an asymptote at those points, you got to look if it cancels out. So if it cancels out like that, that's a whole. And if it doesn't cancel, the x minus 3 doesn't cancel up there, then the point x3 is a vertical asymptote, right? So graphically on this one, if we were to graph it, we would have breaks at 3 and 5, and then at 5 there'd be a whole, and at 3 there'd be a vertical asymptote. So it might look something like that, where there's an asymptote at 3 and a whole at 5. Okay, so that's it for the graphing stuff. Now we're going to go into like simplifying, adding, subtracting, multiplying, dividing rational expressions. That's what we did in the back half of chapter 8. So here we want to simplify and state any restrictions. So pause the video and give it a shot. All right, so to simplify, you want to factor and cancel. So there's no GCFs in either one of these, but we can do y and y for y squared. And then it's got to multiply to 4 and add to 5. So I think plus 1 and plus 4. And then on the bottom, we're going to have a negative, at least one negative. I think it's going to be one negative, one positive. If it has to multiply to negative, then we need one of each. And I think negative 7 plus 1 would work. Okay, and then as far as simplifying it, once you got it factored apart, now cancel. Now we can cancel these y plus 1s. So we have y plus 4 over y minus 7. Okay, and restrictions are kind of like discontinuities. In fact, they're pretty much the same thing. Just think about what number for y would create a divide by 0. Whenever you have a fraction, you don't want to divide by 0. So just look at these little two parts, set them to 0, and we'd have restrictions of 7 and negative 1. So this one would have two restrictions. And don't look at the answer, look at any point in the question, if the denominator is 0, it counts as a restriction. So here we have 7 and negative 1. Okay, so a multiply one is really just the same thing as a simplify, right? This is basically one big simplify, right? Because before we do any multiplying, we want to factor and cancel. So it seems kind of weird, but I'm going to actually write b squared as b times b, and you'll see why in a second. Okay, and then b minus 5, nothing to do there. Up top, I'm going to break it into two little binomials. So we have b and b. And then they must both be negative because we're multiplying up to a positive but adding to a negative. And so make a list for 20, right? If you struggle, do 1 and 20, 2 and 10, 4 and 5. Keep going until you find the ones you need, but I think 5 and 4 should work. Okay, and then here we want to factor out a GCF, right? So they both have B in common, so I'm going to pull a B to the front, right? And we can see if it factors anymore, but really that's all it's going to all that's going to factor. Okay, and now I'm going to cancel. And so obviously we have b minus 5s that cancel. We have b minus 4s that cancel. And then the trick here is now we have like b times b and b. So one of these times b's will cancel out with that one. So we're left with, on the top, we just have b, and on the denominator, we just have 1. You'll always have at least 1 in the denominator. So really our answer is just b here. Okay, and then as far as restrictions go, if any denominator is 0, it's a problem. So from this little factor, a restriction is 5. From this one, it's 4. And then the one students often forget about is if you have a times b, that's going to make a restriction of 0. And if you think about it, if you go back here to this denominator, if b is 0, you have 0 squared minus 4 times 0. So you'd have 0 minus 0, and then you'd be dividing by 0. So long story short, if you have a times b in your factored form, that's going to lead to restriction of 0. All right, thanks for watching.